Okay, YouTube, in this video and in this section, really, we're going to focus on solving exponential and logarithmic equations, or at least equations that involve exponential expressions or logarithmic expressions, how we can rewrite them in order to more easily solve them. So in terms of strategies that we have here, you're going to notice that on the left that I've got listed exponential, on the right we have listed logarithm. So at least for exponential equations, let's take a look at what we would kind of do or have as a checklist to use as strategies to solve them. So the first one is this one-to-one property. Remember, this basically says that if I have a base b to the x power, that's equal to the base b to the y, what we're going to end up with here is an expression or an equation that implies that x and y would have to be the same thing. So this is by far, I would say, like one of the easiest methods to use when you solve an exponential equation. But also this, we can rewrite it as a logarithm. So this first equation up here, we're going to use the one-to-one property, but then we're also going to rewrite it using a logarithm and show that you get the same thing, okay? For the next examples, though, we're going to be solving logarithmic equations or equations involving logarithmic expressions. And in order to do that, we could also use the one-to-one property. Recall that if I had log base b of x and this were equal to log base b of y and they are identical, then we would say, well, then this would imply that x is the same thing as y. So one-to-one applies to logarithmic things just as it applies to exponential things, just a little bit different form. And then also, one thing we could do is just rewrite it as an exponent, just like we would write an exponential thing as a logarithm. We could rewrite a logarithmic thing as an exponent. And also we can use the properties of logarithms. So let's take a look at this first equation up here. I notice that this is definitely exponential because we have our variable up in the exponent. So now that I've identified this is exponential, what we're going to do is this. One, we're going to isolate the base. And by the base, what we mean is really just this thing that's being taken to this exponential power here that has a variable in it. Since we're solving for that variable, we're going to isolate its base if at all possible. So the first thing I'm inclined to do is to get rid of this 2 out front. We're going to divide both sides by 2. So I end up with this right here. We say 5 to the 2x plus 3, and this is equal to 16. So now what I thought we could use one-to-one on, I was looking out of the corner of my eye. One-to-one property is actually not going to work here because I noticed that 16 is not a power of 5, or 5 is not a power of 16, so we're not going to be able to rewrite this using the one-to-one property. However, once we've isolated the base, the next thing we're going to do is rewrite if necessary. And in this case, I'm going to rewrite if necessary. I'm going to leave that general because if it's an exponential thing, we're going to write it as a logarithmic thing, and then vice versa. If it's logarithmic, we're going to rewrite it exponentially. So when we rewrite this as a logarithm, remember that we have an expression here where we have something to the power of an exponent equals this thing. When we write this as a logarithm, what we're going to instead do is write log base. Now the base would be the same as this base here, so we say 5. And what happens is 5 is turning into the 16. So log base 5 of 16, 5 will turn into 16 if we take it to the power of 2x plus 3, which is this exponent right here. So looking at this, you can see how easily we could actually just go evaluate this now. And let me get my calculator fired up while we're talking about this. But evaluate it. I guess I meant solve this. So what we could do is it looks like subtract 3 from both sides is going to be our next step here. I'm just trying to get ourselves set up. Okay, so we're going to subtract 3 from both sides of this equation now that we're, got x on the ground and we're solving for x. We would say then 2x would be equal to this. Now we would write log base 5 of 16 minus 3. And then the last thing we would do is divide everything here by 2. So looking out over here, we would say that I have x on the right side, and on the left side, we just have all this stuff. We have log base 5 of 16. We had subtracted 3. Oh, I want to fix that 16. Subtracted 3 off of that, and then we divided everything in half. So now what we need to do is box this, first of all, because this is the exact value of x. We can plug this back in, and we would see that we would get a true statement here. But in this particular case, I want to get a decimal. So using our calculator now, what we're going to do is we're going to find all of this stuff here, starting with our log base 5 of 16. Now, because we don't have a log base 5 button, what we're going to have to rely upon is doing the change of base formula. So we're going to say, how about this? We'll do ln. ln of 16 over ln of 5. That minus 3, and then all of this here, we're going to divide by 2, and this will be our x. So I am going to start with that ln 16 divided by ln 5. So ln 16 end parenthesis divided by ln 5 end parenthesis. Then we're going to subtract 3 from our answer there, and then we're going to divide that answer by 2. So divided by 2. And what we end up with out to 3 decimal places is approximately negative 0.639. So we get approximately negative 0.639 for our x value. This would be easy to check. So again, all we did was we isolated the base and then we rewrote it if necessary. Now when we look at this next example, this is on here on purpose. I hope you recognize that this right here is in somewhat of a quadratic form. Now when we mention quadratic form, this would be something like x to the fourth plus, 4x squared plus 3. The reason why this is in quadratic form is because we have some trinomial here where our powers can be rewritten in this form, x squared squared plus 4 times x squared to the first plus 3. And so we could factor this just kind of like we would x squared plus 4x to the first plus 3 by writing instead x squared, and then it looks like we'd have a plus 3 and a plus 1. The same thing is going to happen here, except for up in the exponents we don't have a 4 and a 2, we have like 2x and an x. So our method of solving this, it's not going to work to get the base by itself when we have two different bases here, to different exponents that is. We can't combine like terms. So what we're going to do is we're going to write in our e to the x here and e to the x here. And the reason why is because if I were to take e to the x times e to the x, if I FOIL this back out, I would have e to the x plus x, which is e to the 2x. So we do indeed obtain this e to the 2x in front. Now in the back, what two numbers can I multiply out to be a positive 6 that add up to be a negative 5? I can think of a negative 3 and a negative 2. And it would be easy to check this to see we get what we need. We would get our e to the 2x, and then minus 2e to the x, minus 3e to the x is negative 5 of those e's to the x, and then we get our plus 6. So using these factors now, we say e to the x minus 3 either equals 0, or e to the x minus 2 equals 0. And you'll notice that we end up with a situation just like with up here where we said we can isolate the base now. So in this first equation, the base is e, and the second equation, as a matter of fact, the base is e. So we're going to take these constants in either equation in this particular case and put them on the other side. So we get e to the x equals 3 and e to the x equals 2. We certainly want to be able to answer this. So what we're going to do is we're going to rewrite these as a logarithm. The only reason I say that is because I can't rewrite e as a power of 3 or 3 as a power of e. We can't use 1 to 1. So if we rewrite this as a logarithm, we would have log, what's our base here? Well, it'll be base e, and e turns into 3. So log base e of 3 equals x. So here's our logarithm. By the way, I would also write this as x equals ln of 3 because log base e is the natural log, and this is how we should write it. So we have ln 3, and then also this over here, if we rewrite this, we would say ln. Now, we'd say ln of what? Well, our base here, well, let's put it this way. If we had a log base e, e turns into 2 by taking it to the power of x. So we would have ln of 2 is equal to x here. So these two we're just going to find really quickly on our calculator. We say ln3, enter. ln2, enter. So we get approximately 1.099 for this value over here. So we say x is approximately 1.099. And x here is approximately, and we'll just go back and look here again, this calculator, 0.693. So we have 0.693. So in this next video, we're going to look at how we solve logarithmic equations. Cheers.